question that I'm often asked is, why aluminium? Why are you studying aluminium? Well, the answer for me, now at least, is relatively easy. Aluminium is the third most abundant element in the Earth's crust, and it's the most abundant metal. That in itself makes it interesting. But when you combine that with the fact that aluminium has no known biological function in any living organism, or indeed there is no evidence that aluminium has had any biological function in any organism, either extinct or living. And this creates a paradox for us. The paradox being that the majority of abundant metals, abundant elements, are indeed essential. They are used by living things. So this paradox has been the subject of my research for over 30 years, and indeed is the subject of the research of my group. And one of the ways that we investigate this paradox is, in some ways, to try to identify possible functions for aluminium. But in doing so, of course, you also come across ways in which aluminium is inimical to life, in which it is, in fact, toxic to living things. And this is where I started my research, trying to work out how aluminium was toxic in fish. And we know now that all of the problems associated with acid rain, where fish were dying in acid lakes, where trees and great forests were dying, these were due not to the acidity of the rain, but to the fact that the rain released aluminium, previously inert, from the soils, so that it became biologically available and produced toxicity in the fish, the trees, and other things. So aluminium is one of, if not the most ubiquitous and significant contaminant or toxicant on the planet, on our Earth. And there are innumerable examples today of how it is beginning to exert some sort of toxicity on many other living things. So, for example, very recently, we have measured aluminium in bumblebee larvae, because we're interested in whether aluminium could be playing a role in why we are losing many of our pollinators, not just in the United Kingdom, but all over the world. And indeed what we've found is that the bumblebee larvae are indeed full of aluminium. So in some form or other, those bees are being exposed to aluminium, and it is accumulating within their life cycle. It's a rather interesting analogy with humans, because what we know is that the way in which a bee is exposed to aluminium is most likely through, for example, nectar, and indeed through pollen. And experiments have shown that when a bee takes nectar which contains aluminium, it doesn't notice its presence. It doesn't try to avoid it. It essentially takes the nectar, and eventually that nectar can get used or fed on to grubs and gets into the particular life cycle. In other words, it's a covert type effect. And I would probably suggest that in humans it's exactly the same thing. Aluminium is a covert toxicant to humans as opposed to overt. It's rare, very rare, that you would go and see your doctor and say, "Oh, I think I've been poisoned with aluminium." It wouldn't happen. It's highly unlikely. However, you may well be suffering some sort of toxicity due to aluminium, but neither you nor indeed your doctor would be able to diagnose that. So our exposure to aluminium is something that happens in our everyday life. We can't avoid it. In the main, we don't even notice it. We're not sure whether we have a chronic intoxication or not. For example, is the fact that you're a little bit more tired than you usually are, is that just a normal phenomenon for you, or is it in fact something to do with and exposure to aluminium over particular periods of time. It could be, we simply don't know this. So one of our roles here at Keele has been a program we call Human Exposure to Aluminium. And that program has been trying to understand not only the many different ways we're exposed to aluminium in our everyday life, but where does it go and where does it go in the body? And as part of that, of course, our work has centred on some of the more controversial areas. For example, the role that aluminium might play in Alzheimer's disease. And in relation to that, we have, over the last 5 or 10 years now, analysed, well, in excess probably of 100 human brains, looking for the aluminium content of those human brains. Some brains from people with Alzheimer's, some from aged people, some from people with other conditions. One of the really surprising, I think surprising at least, observations that we've made in that research is actually how much aluminium there is in the human brain. So we now know for absolutely for sure that we are, simply by living our everyday lives, we are accumulating aluminium in our brain tissue. Now, aluminium is not an inert metal in respect of biology. We know that aluminium is toxic, as we have seen with fish and trees, now with bumblebees, and indeed in many animal models of aluminium intoxication. So we can't, I think, afford to be complacent about this observation that we are accumulating aluminium to a significant degree in our brain tissue. And indeed, I have been thinking about this for a long time, many, many years, and I have had to come to the conclusion that the amount of aluminium we are now accumulating in our brain, and we are all different, our physiologies are different, so some people will accumulate more than others for different reasons, and we don't understand those reasons. But when that aluminium content reaches a threshold of some sort, that aluminium will contribute to disease in that brain. And if, for example, Alzheimer's disease of some sort was ongoing, perhaps in very early stages in that brain tissue, and concomitant with that was this high level of aluminium, then I am absolutely convinced that aluminium would contribute to that disease. Contribute perhaps by making the disease occur at an earlier stage of life, an earlier onset, and it might even contribute by making it more aggressive. And we've actually published a number of case studies which support that view. Now, this on the surface sort of sounds like bad news. It isn't completely bad news. I write about and talk about us living in the aluminium age. We can't avoid aluminium in our everyday life. Aluminium has done fantastic things for us. We have used it in many different positive ways. We are not going to take aluminium out of our life. In fact, we are going to continue to use aluminium more tomorrow than we did today, and more again in the future. So the question is, how can we continue to live in the aluminium age, but to live safely and effectively, continuing to use aluminium? And we believe we have a solution to that. And our solution came from my early research, PhD research on aluminium toxicity in fish, because in that research I showed that silicon protects against the toxicity of aluminium. And in many ways we should have been able to guess this, because aluminium in the Earth's crust is made of aluminium, silicon and oxygen. When man decided to take that aluminium from the Earth's crust and create aluminium metal and aluminium salts with it, he essentially took away the silicon, allowing the aluminium to become biologically available and biologically reactive. So my early PhD research simply said, put the silicon back in, see what happens, and hey presto, what happened was the aluminium was no longer toxic. So over the last 30 years since my PhD, we've been developing this chemistry, and indeed this biochemistry, to to look at a way in which we can use silicon to protect against aluminium in our everyday lives. And what we've found is quite a simple solution, which we hope is a simple solution. And that is, if you take a mineral water, which is rich in silicon, has a high content of silicon, more than 30 parts per million, and you drink that water, the result is that you will excrete aluminium in your urine. Fantastic. You actually remove aluminium from your body by excreting it in your urine. Possibly our most recent research says that not only will you facilitate the removal of aluminium in your urine, but you will also facilitate the removal of aluminium in your sweat as well. So two major routes at which the body gets rid of aluminium, those routes can be improved upon by drinking silicon-rich mineral waters. And what this means potentially for us is that we have a way of lowering what I call the body burden of aluminium, how much aluminium there is in the body. And if we can lower the body burden of aluminium to as low a practical limit as possible by simply introducing a silicon-rich mineral water into your everyday life, then we can also test whether or not your aluminium body burden is toxic to you, whether your body is having to expend energy to deal with it, and indeed whether or not aluminium has a role to play in Alzheimer's disease. So we're going to extend this hypothesis now to test whether or not lowering the body burden of aluminium by regular drinking of a silicon-rich mineral water can impact upon Alzheimer's disease. This is the first opportunity ever to test what's known as the aluminium Alzheimer's hypothesis. Does aluminium have a role in Alzheimer's disease? The idea behind this clinical trial will be to recruit individuals in the early stages of Alzheimer's disease and give them and ask them to drink around 1 litre of a silicon-rich mineral water every day. And they will do this for periods up to 24 months, maybe longer, depending upon how much research funding we are able to gain through this process. But we will ask them to continue to drink a silicon-rich mineral water, and during that time we will monitor the progress of their disease. So essentially our working hypothesis says that if we are able to in some way alter the progress of their disease, maybe prevent it from progressing by simply drinking a silicon-rich mineral water which is helping them to excrete aluminium, then we would be able to show and demonstrate that aluminium does play a role in the disease. We're not saying that it's necessarily going to be a cause of the disease. This particular trial will not be able to ascertain that. This trial is simply to say, if we are able to reduce our exposure to aluminium, increase our excretion of aluminium, can that impact positively on a chronic human disease such as Alzheimer's disease? So this is the great intention that we have from this project. Many people might say, so why are you not just writing a proposal and asking major research councils, major charities to fund something if it's so simple, so non-invasive, with such a possibility of success? And you're right, why aren't we? Well, we have, and we've tried many times. One could probably surmise that the reason why we are not given this opportunity through the usual routes is because perhaps this is a question that not everyone wants to know the answer to. You have to start to accept that the aluminium industry, which has never had to control itself in any way whatsoever in terms of how aluminium, in terms of human exposure to aluminium, there is no legislation relating to human exposure to aluminium. So the industry is totally pervasive. If aluminium was shown to have a role in Alzheimer's disease, then clearly this would have an impact on industry and indeed it would have an impact on government. There would need to be some forms of legislation. There would need to be major changes made. We would not be advocating that aluminium could no longer be used in the myriad positive ways that it is. But actually aluminium is usually present in most of the aspects of our life as a contaminant or as a very cheap alternative to something else. And perhaps those aspects of the way in which you use aluminium would need to be addressed, along with drinking silicon-rich mineral waters. And there can be very little problem for people to have a litre of water a day in their diet to protect them against the potential ravages of aluminium and chronic aluminium intoxication. So we will not get this project funded by government or Alzheimer's charities or any other of the normal processes. This is a project for the people. If the people, like myself, believe that this is worth funding, that this hypothesis is worth testing, then you will support us, and we will test this hypothesis, and we will provide an answer one way or the other